In this very lesson, we shall be looking at the application of the laws of indices in solving questions. Remember, in our previous lesson, we were able to deduce the laws and properties of indices. So in this very lesson, we are just going to look at what the application of it in solving questions. So in our previous lessons, these were the laws that we were able to come out with together with the properties. So we are just going to apply these laws and properties in solving the questions on the board. Now, when we talk about simplification of exponential expression, it means that our final answer must be in an exponential form. But when they ask us to evaluate, then we have to find the value of that exponential expression. So with this, we have to simplify. So our final answer must be in an exponential form. Kindly take note of that. So we have we have to simplify this exponential expression. So realize that we have the numerator and then we have the denominator. So looking at the numerator, we have 5 raised to the power 7, 3 raised to the power 5. So the bases are not the same, and therefore we can't apply this law, the multiplication law. But realize that we have 5 and then 5 here. So we can do something so that we can apply the division law. So why don't we rearrange it so that this 5 will come in front so that we have 5 and 5 so that we can apply the division law. So we can write this as 5 raised to the power 7 multiplying 3 raised to the power 5. All over, let's bring the 5 in front, 5 raised to the power 2 multiplying what? 3 raised to the power 2. Now, since multiplication is commutative, it doesn't change anything. When we bring the 5 raised to the power 2 in front, it doesn't change anything. Now, looking at this, we realize that we are having 5 raised to the power 7 divided by 5 raised to the power 2. So we can apply the division law, which says that when two numbers are dividing, they have the same base. What we do is that we pick one of the base, we subtract their exponent. So we can write this as we pick one of the base, we subtract their exponents. We have our multiplication. Applying the division law, when two numbers are dividing, they have the same base, 3, 3. We pick one of the base, and then what do? We subtract their exponents. So we have 5 raised to the power what? 5 multiplying what? 3 raised to the power 3. Since we have to simplify, we have to leave our answer in an exponential form. So we have done very, very easy and then simple. Let's look at our second example. You can pause the video, you try your hands on it. So applying the same concept from here, we can rearrange this by bringing the 7 in front so that we have 7 and then 7. So we can write this as 7 raised to the power 7 multiplying 4 raised to the power 2 all over. Let's bring the 7 raised to the power 5 in front multiplying 4 raised to the power 8. Since multiplication is commutative, when we rearrange it in this form, it doesn't change it. So we are going to have applying what? The division law. When two numbers are dividing, they have the same basis, 7 and 7. We pick one of the base, we will subtract their exponents. So we have times. When two numbers are dividing, they have the same base, 4 and 4. We pick one of the base, which is 4, we subtract their exponents. So we have 7 raised to the power 2 multiplying 4 raised to the power of 4. As easy as that. We have to simplify, so we can leave our answer in this form. Now let's look at our third example. We have to simplify this. Okay, so we have 8x cubed y power 6 divided by the whole of this. So we have a number dividing a number. We have two variables dividing, they have the same base, y and y, they have the same base. So we can apply the division law to simplify this. So we are going to have 8 divided by what? 4. And then we have applying the law of indices. When two numbers are dividing, we pick one of the base, we subtract their what? Exponents. And then we apply the same division law here. We have y raised to the power 6 minus what? 3. So at the end, we are going to have 8 divided by 4 will give us what? It will give us 2. And then we have x. This will give us what? 8. And then we have y. This will give us what? 3. As easy as A, B, C, D. Let's take our next example. So we have our next examples. We have to simplify this 2d squared multiplying 5ad squared all over 4d cubed. So we have a bracket inside. First of all, let's remove the bracket. Okay. So we can remove the bracket by expanding. So we have 2 times 5 will give us what? 10. And then we have our a. So we have d squared multiplying what? D squared. The bases are the same and they are multiplying, applying the multiplication, or we pick one of the base, we add their exponents. So this is going to give us what? D raised to the power 4. All over what? 4d raised to the power 3. So we have 10 divided by 5, and then we have only a here, but we have d and d. So we can apply the division law to simplify this. So we know that 10 divided by 4 give us what? 5 all over what? 2. Since we are only having a, we just write it. But we have d and d here. Applying the division law, when you have two numbers dividing, they have the same base, d and d. You pick one of the base, you subtract their exponents. So we are going to get d raised to the power 4 minus what? 3. So then we are going to have 5 all over 2 a, and then 4 minus 2 give us what? 1. So we have 5 over 2 and then 80. Very, very easy and then simple. Let's look at this example. We have 27 times 125 all raised to the power 1 over 3. Exponent of 1 over 3. So with this, we can write it as 27 raised to the power 1 over 3 multiplying 125 raised to the power 1 over 3. Remember, when you have a, b raised to the power n, you can write it as a, n, and then b, n. That is the power law extension. So we know that 27 can be written in an index form as what? 3 raised to the power 3. Because 3 raised to the power 3 gives us 3 times 3 times 3, and this gives us 27. So in place of 27, we can write 3 raised to the power 3, and then we have what? 1 over 3. Now 125 can also be written in an index form as 5 raised to the power 3. And this is 5 times 5 times 5. This gives us 25, 125. So in place of 125, we can write it as an index form as 5 raised to the power 3. So we have 5 raised to the power 3, and then we have 1 over 3. So for me, applying the power law, this one, we can write this as 3 raised to the power 3 times 1 over 3, and then we have 5 raised to the power 3 times what? 1 over 3. So we can see that these 3 can cancel these 3. We are left with what? We are left with 3. These 3 can cancel these 3. We are left with what? 5. We can evaluate to give us what? 15. As easy as that. Now let's look at the last one. We have to evaluate 16 raised to the power 1 over 3 multiplying what? 4 raised to the power 3. So with this, we know that 16 can be written in an index form as what? As 2 raised to the power 4. Because 2 times 2 times 2 will give us what? 16. And we can write it as what? 2 raised to the power 4. So we can write it as 2 raised to the power 4 or raised to the power 1 over 3. And we know that 4 can also be written in an index form as what? 2 raised to the power 2. And then we have 1 over 3. So applying the power law, we can write this as 2 raised to the power 4 over what? 3. And then we have 2 raised to the power 2 over what? 3. Now we have two numbers multiplying, they have the same base. Applying the multiplication law, we pick one of the base, we add their exponents. So we are going to have 2 raised to the power 4 over 3 plus what? 2 over 3. And this is going to give us 2, we have what? 6 all over 3. We can break it down as 2 raised to the power 2. And that is what? 4. Since we have to evaluate, we have to find the value. Let's look at our next examples. So we have our 7th example. We have to simplify this exponential expression. So we said that from this property, the radical sign or the root sign is the same as what? A power of half. So we can write this as what? That, because the root sign is the same as what? A power of half. So from here we can apply our division law. So we have 36 divided by 4 will give us what? 9. And then applying the law of indices, the division law of indices, when two numbers are divided, they have the same base. We pick one of the base. What do? We subtract their exponents. Now let's move on to the y. So we have y raised to the power 3 minus another minus 3. And then remember we have the power of half here. So we are going to have 9. This is going to give us s raised to the power minus 6. And then we have y raised to the power what? 6, all raised to the power of half. We know that 9 can be written in an index form as what? 3 raised to the power 2, because 3 times 3 gives us 9. And we can write this as 3 raised to the power 2. So in place of 9, we are going to have 3 raised to the power 2. And then we have s raised to the power minus 6, y raised to the power positive 6. So all raised to the power half. So let's continue from here. Now with this, applying the power law, which is this, we can write this as 3 raised to the power 2. Then we have times 1 over 2. And then we have x raised to the power minus 6 times 1 over 2. We have y raised to the power positive 6 times 1 over 2. So we can see that these two can cancel these two. We are left with what? 3. These two will cancel negative 6. We have negative 3. So we have x raised to the power minus 3. And then we have y raised to the power positive 3. So this is the simplification of this exponential expression. Now let's look at the next example here. Now with this example, we have the power negative 2 all over 3. Now we know that the number 125 can be written in an index form as what? 5 raised to the power 3. So we have 5 raised to the power 3 all raised to the power 2 over 3. And then 16 can also be written in an index form as what? 2 raised to the power 4 all raised to the power of 3 over 4. And then the number 8 can also be written in an index form as 2 raised to the power 3 all raised to the power minus 2 over 3. Applying the power law, we can have 5 raised to the power 3 multiplying 2 over 3 plus 2 raised to the power 4. Applying the power law, we have 3 over 4. Then we have 2 raised to the power 3 and then times minus 2 all over 3. So we can observe that this can cancel this. We are left with 5 raised to the power 2 plus this 4 cancel this 4. We are left with 2 raised to the power 3 plus this will cancel this. We have 2 raised to the power minus 2. So we know that we have to evaluate. So we know that 5 raised to the power 2 give us what? To give us 25. and then 2 raised to the power 3 will give us 8. So we can write this as what? 1 over 2 raised to the power 2. That is applying the property of negative index. So this is going to give us what? 33 plus what? 1 over 4. And this gives us 33 and then 1 over 4. And that is that. This brings us to the end of today's lesson. I'm going to give you one tutorial set question. Pause the video, write it down, you try your hands on it. So this is your tutorial set question. The suggested answer is 1 over 2 raised to the power n. Try your hands on it. See you tomorrow. Bye bye.